Hello everybody and welcome to Handmade Hero, the show where we code a complete game live on stream. We have done a bunch of work with our renderer to make it a lot more efficient in hardware. Really has nothing to do with renders in general. It was mostly just a case of hardware really doesn't like texture changes if you're on certain types of cards. Other types of cards don't mind. And so we kind of needed to have a solution to that problem. And so what we did is we started using texture arrays, and we have much better throughput than we did before. We still got other issues in the renderer that we'll have to address at some point that have to do with performance. Right now we're using way too much memory due to the way we're handling our back buffers. Right now we're doing some stuff with depth pilling and multi-sampling and stuff like that that's just it's a little too piggy. And so we're probably going to have to do some work to make sure that those things are a little bit more frugal. And we also are doing some things right now with respect to texture usage that are absurd. For example, right now, everything's a 512 by 512 texture, but we've never updated the fonts to, for example, be packed into a single texture. So right now, like every letter of a font, I believe, will get its own 512 by 512 bitmap, into which it will pack a little tiny character in the upper left corner, is what is actually happening. As you might imagine, that is not particularly useful or necessary. So we will want to do some work ship-wise on that sort of stuff down the line. However, I don't really know that we care about it at the moment, especially because, you know, if we take up 50 of our texture slots with random characters or something, it doesn't really affect our ability to develop the game. We're still getting totally fine frame rates and everything else, and the only thing that we have right now that's a bit slow is lighting, which of course we can always turn off for development if we need to, and we will eventually improve that anyway. So that's really not a big deal. So I would say let's just leave it for now. It's in a good state. It's a pretty reasonable system. I think what we want to do now is focus on the asset system and the asset tagging. And we have a pretty clear path for that. Really what we just want to do is iterate on it until we think it's in a good place. And the way we're going to do that is, right now our world is very barren. We can create rooms and hop around them and do whatever we want. But what we cannot do is really decorate them much, because we just don't have we don't have an answer for how we want to bind our input assets to what we see on the screen. And so that's really the challenge that we got to face. And this is actually, I would actually argue this is one of the most difficult things in game programming. And the reason why it doesn't appear difficult most of the time is because most of the time people don't really end up solving it. And we're not going to solve it fully on Handmade Hero either, because my feeling is that the actual solution to it, which I think is the more appropriate one, actually involves such a huge step forward in terms of game development systems and things like that, that it's impractical to consider on a project where we only code 2 hours a day, 2 days a week. So we'll put that aside and just say that asset binding is a very difficult problem. And most of the time the way it is solved, much like NP-complete problems, is you don't really solve the problem, you solve an easier problem that gets you most of what you want, and you accept some of the compromises. So that's really all we're looking for. And again, it just has to work in order for our game to run and do what we need it to do. It doesn't have to be perfect in order to ship. In fact, if things had to be perfect to ship, we'd probably never ship anything. So anyway, we know that we did the cutscenes as well, and those all seem to be working. We double-checked those. So here's the game running just fine, but as you can see, everything is just cubes, blank cubes, and we don't want a game full of blank cubes. What we want to do is put things on the cubes, and in addition to putting things on the cubes, we also want to be able to put items in the rooms and that sort of stuff, right? Because we've got little items that we can put in there. But right now, if we put an item in there, it would just be another blank cube or something. And we do have a fairly kind of poor system right now for picking some assets, and that's how we made like the hero pick the head asset and so on, and we can, you know, do some stuff here in terms of turning the hero and so on, but it really isn't that good. And so what we want to do is we want to now actually create a real answer to this problem, right? We've got most of our stuff working in a pretty reasonable way, and so what we would like to do here is we'd like to come up with some kind of an answer as to how we're really going to do this. And I feel like the best way to do it is to actually try to make an orphanage filled with the stuff that we think should really be there, and also fix the hero. The hero is still using the old assets. We have new assets for the hero that are at the right perspective. This is kind of at the wrong perspective. So all those sorts of things really want to happen at some point here. And I think now is that point, right? That now is the time that we want to try to get that all working. We should probably fix our debug system to snap these to the corners too. I don't know when we lost that snapping. I think we changed to like pixel coordinates at some point rather than like percentage-based coordinates or something, and we lost a little bit of something there. So anyway, that's really what I want to do, and I feel like the things we can focus on in the short term to try and like drive that, because we've got a few things here we can really clearly focus on. One of them is get the right sprites for the hero. The other is the walls provide a really good opportunity for working on the asset tagging, because there's actually some fairly complex stuff that has to happen with those wall textures. If you look at what we've got in terms of what goes on to the walls art-wise, right? In the Handmade art directory, we've got example assets from Anna that are what things, test things. And what you can see here is, right, like there's these textures that have panels, and those panels are semantic. Like this is clearly the beginning of a run, this is the middle of a run, this is the end of a run, and this is for one like isolated one that doesn't have a run, you know? And so, and like that's for the top and these are for the bottoms, you know? And so if we looked at something like that, we know that the assignment of those has to be like coming from the procedural generator, because only the procedural generator is going to know, oh, you know, I wanted this to be a continuous run of this wall, so each one of these things should be that way. And furthermore, like, you know, the procedural generator probably wants to think in terms of should these things be staggered heights or all the same height so that they look continuous or not, right? And all of those sorts of things are pretty important for getting it right, you know? So we want to come up with a very good system for describing those things that makes it easy for us to do what we need to do here. Now, if we look, you can see that we've got a couple different types of orphanage blocks as well. These are like floor tiles, for example, and these are stone floor tiles, right? So we have two different types of floor tiles there, and then these are like wall tiles, you know? And here's an example of a forest, simple forest ground tile too, you know? We've got trees, we've got furniture to place, right? And so we want to try and conceptualize what's the easiest way for our code in the generator to articulate things into the world that will then select the right assets. And the most primitive way of doing that would just be to explicitly say what the asset is. You know, and maybe that's what we go with. There's the notion of having some matching. We have some of that in there now. And finding the balance between those is going to be important. Sometimes you cannot articulate the entire thing, and the hero would be a good example of that. The hero is an entity in the world, but the hero can turn, right? So if we were to just say explicitly what the hero is, then he couldn't turn because the parameter of what direction the hero is facing couldn't be used. You just have explicit bitmaps, right? So it might be fine for a wall to have that, but it wouldn't be fine to hero to have that. Extending it a little bit further, it might also not be fine for a wall to have that. Why? Well, let's suppose we wanted walls when we hit them to show damage. Well, if a damaged wall is a different asset from a wall, then if all you know about the wall is that it is having this particular texture on it, you wouldn't know what texture to look for when it got damaged. So you can see how raising it up one level and saying, well, I'm going to specify a class of possible things that are on this wall with at least one parameter, which is how damaged it is, gives you the ability to specify something at the generator that is what you wanted to say, but then have a match occur later on in the pipeline that allows the artist to put more things in that can show response to some parameter. Does this make sense? And so again, this is why I say this is a very, very sensitive part of the pipeline. In other news, I'm wondering why we're having weird, I think this might be a fog-based issue. There's some kind of weirdness with, like, if you look at this, all of the alpha blending looks totally right. You see what I'm saying? It looks perfect. Really, really good, right? And remember, this is order independent, so that's pretty awesome that the render is doing that. It's great. But like that is wrong. And I think it's because it's getting fogged. I feel like the alpha is getting fogged wrong. You know what I'm saying to you? And I guess I can prove that by the fact that this looks fine, even in the same exact way, and the only difference here is that the fog is turned off. So we've got a fog bug. You know what? Why don't I go and log that in our fancy GitHub? All right, there we go. I've had to learn how to use GitHub because I released the meow hash as open source, and it seems like people all use GitHub for that sort of thing. So I had to learn how to use GitHub, which was a real treat, let me tell you. But so I sort of vaguely know my way around it now. It's not pretty, but for example, I at least know the basics. Like I can make new branches, put stuff in there, merge them in, and comment and all that stuff. So I had to learn to do all that stuff reluctantly. But it does mean that I can at least use the Handmade hero one more now, which of course I never really did. I just made a script that would update it, and I never looked at it again, more or less. But I do sort of know how to use it now, and I can at least use this stuff reasonably. So, there we have it. So anyway, what I want to do is focus on that for the next few weeks, because that will take our game from something that's very prototype looking to something that actually starts to look quite game-like. The difference between something that looks like a prototype and something that looks like a game is art. I mean, people ship entire games where the gameplay is terrible, so it's not gameplay that differentiates a prototype from a finished product, sadly, but art definitely does. So you look at this screenshot and it clearly looks like a prototype because everything is fairly blocky. I mean, granted, you know, Minecraft, one of the best-selling games of all time, doesn't look particularly different than this, but that's a separate issue, I suppose. You can't compare things to Minecraft, it's sort of an anomaly. Most of the time, if you look at a game that looks like this, you know that it's a prototype because it clearly doesn't have much art in it. So really what we want to do is take our game from looking like a prototype to looking like more of an actual game, and that just involves having, art assets in place and looking like they belong there. So that's what we're going to try and do now, and we want to try and move that as far down as we can to something that looks, if not shippable, then at least on the way to shippable and sane. So I'm going to go ahead and build the game here just to make sure everything is still working properly. Looks like everything is. Oops, don't ask me why I've got two for coders open. I guess I got a little overzealous there. But if you recall, the way that we were doing this previously is that inside the asset system, we've got a bunch of different ways that this sort of stuff works. But we have these things called asset vectors. And an asset vector basically has a tag count, and the tag count is something that's specified in the HHAs here. So we've got this notion that any individual asset can sort of depend on or specify a series of parameters, right? And on top of that, we also had a type system. So we would say something like, okay, this thing here, this asset shadow or asset tree, sword, rock, grass, tuft, stone, those sorts of things, right? All of those things were also a sort of orthogonal way of selecting things. So you could also say, in addition to saying, here's some tags, and each tag has a parameter. So, if I said, well, let me actually load up the tags here. They should be here somewhere. There it is. So the tags are things like smoothness, flatness, facing direction, Unicode code point, font type, shot index, primacy, blah, 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 right? And the difference between a tag and a type is just a category of objects. So you basically say, look, this is what I'm looking for. Whereas a tag is a thing that says, here's a parameter. Like, I don't just say that something is flatness. I say that it has flatness of 0.4, right? And then when I go to pick an asset, I say, here is a type of asset, and here is the tag, right? And so on. So that was sort of the way that we had things going, and I mean, it's okay. We could keep going that way. It's a little off. It's just not quite right. And so I want to try and take the approach of Snuffleupagus-oriented programming, which we've done before. And Snuffleupagus-oriented programming, if you'll remember, SOP is when we basically say, look, we don't really know what we're doing here. We don't have a strong opinion about how we want this code to work. But we know that we want it to work, and we want it to work well. So let's start on the side that uses the system, and let's see what we would type in if we imagined that we had the perfect system on the other side. So just put it out of your mind how it works. It's magical. It's just gonna appear somehow with pixie dust and unicorns. Snuffleupagus just comes and saves the day. It's fine. What would we write in that case? And then we use what we come up with there by focusing on the imaginative perfect system to then inform our design of the actual system, which we then have some idea of what we might want, right? So it's kind of a way of generating some requirements when you don't really know what they are yet, right? Sometimes you go into a piece of code, you know exactly what it should do. And so the goal is just to write a piece of code that satisfies those things that you want the code to do. Other times you're dealing with something much more conceptual and abstract. In this case, that's exactly what we have. We know we want some way of talking about these art assets that works well for the code we need to write for the gameplay, but we don't really know what that would be. We don't know exactly what the best type of code would be, calls would be for this system. So this is a way of us getting insight into what that should be. It's just imagine we could call anything we want at any time. What do we end up typing in? So let's pop into the world generator code and try some stuff. So here's the couple things I want to try. First of all, I'm going to take a look at code that generates a room. And I'm going to say for the code that generates a room, I want to do the basic step that I was just talking about just a moment ago, which is let's figure out how we might state that we want to put those orphanage wall blocks in there. So, you know, this stuff, how would I say that I want to put like these on the floor, and maybe I randomly want to pick, you know, different ones of these, because these are just tests. Imagine when Anna actually does them eventually, these will probably be somewhat different, a little more than that maybe, or maybe not. Like maybe we just, we don't want that much variance, I don't know. But point being, you know, we want to be able to randomly pick from some of those. We want to be able to make these work properly, where we have, depending on where it is in the run, it selects the right panel out of the art, right? So let's see how we're going to say that and how we're going to encode that in the entity. And then based on what we've come up with there, then we'll have some idea of what to code on the other side when the entity goes to actually render. So there we go. All right, I think, how much time we have left? Half hour? Is that right? When did we start? We started at 12:30. Oh, no. We've only been doing for we've got an hour, hour and a half. All right. So in here, when we go to place a room, and again, this is just some basic generation code we made. It's nothing particularly special. But what you can see here is we then have sort of some code which will go in there, and for example, here it's doing some work to sort of put rooms in place, but I think this just puts the rooms there, right? Yeah, I think so. So this is probably the code I really want to look at, because we don't really need to deal with it at a higher level. We can deal with it right when we're actually splatting down the tiles. So this, for example, is where we're splatting down those tiles. And you can see us adding in the pieces here. And you can see us just kind of, what we randomly do is slap down something asset grass here, which is probably pretty meaningless. And that's just what we called the cube type that was there, right? Cubes at the moment don't even get textures on them in our system. We have the ability to do so, we just don't even use it. So this is what generates all of those entities, and what we want to do is be able to generate the correct wall tiles for each of these. So what you can see here is inside this, inside all of this generation code, mostly what we're doing is we're putting entities on. And the way that we're putting entities into the world is we start by adding an entity, we end by placing it somewhere, and in between, right, we often do stuff like this where we add pieces to the entity. And the reason we have this notion is that an entity is sort of a logical construct that we think of as, you know, there's a wall here, or there's a player here. But that individual semantic construct that we're programming with may itself be composed of smaller pieces that we don't think about separately, other than to produce the visuals. And so that's what the idea is behind the piece is. A wall could have two different pieces to it. Like if there was a weird floating eye on a pedestal or something, right? That always just wanted to be talked about together because they never really were able to be separated or anything like that. But you want to be able to control their animation, or, you know, how they're rendered. We've got this notion that an entity can have multiple pieces. Excuse me. And so the piece concept is really what encodes how an entity's visuals are presented. And so we want a way of specifying those. That's actually what we're trying to do here. We want a way of specifying those such that we can capture the specificity that we were talking about with the texturing, right? So that's where we would need to encode what parts of this we were expecting to have happen, right? So let's say that I wanted to move over to let's say that I move over to the entity system here, and we've got the definition. Remember, the entity system will be finalized later, so this is kind of, we can do whatever we want here. We can literally just do anything that comes to mind. We don't have to think about doing anything well. We can just throw anything in here, and this will be dealt with later. That's intentional, very intentional. So you look at this, one of the things that it looks like to me, sort of, right, is we've got these entity pieces here. It's called entity visible piece. You can see that it encodes a few things. And they're not that bad, honestly. Is light index still used? It's not. I didn't think it was. They're not that bad, right? We know that it's got some color. We know that it's got an offset from wherever the entity is. We know that it has an asset type, which is how we select. I don't know really why it's there. I think that's how I would normally do it, right? So we've got our vector here, and then we've got sort of our flags and type down here. But so we have our color, our offset, and we've got our dimensions. The dimensions probably should be 3-dimensional rather than 2-dimensional if we're in keeping sort of with the fact that now things generally exist in 3 dimensions. We can always just ignore the Z for things that are flat, but I think we probably want I think we want everything to sort of be conceptually a cube, even if we don't render it as a cube, especially because we may need to absorb light and stuff in our final lighting. We want to kind of know what that is. So I'm going to start with just some basics here. I'm going to make this into 3-dimensional, which shouldn't really require much, because now in here where we're doing add piece, we can just force people to specify 3-dimensional things, and they can just specify the final component as 0 if that's actually what they wanted. So in here where we're adding a piece, we'll just say, look, there's the dimension, and it's fine. Then in here where we're doing this sort of thing, instead of a v2 where we just do 0 in the height for those sorts of things. Of course, I don't really know why we specify it that way, but I guess we do. You know, we can just put this in here for now, like so. And for this one, I guess in here we can just say radius, radius, radius. This kind of sounds like kind of funny there. Yeah, same here. So in here we know that we've got the wall height. I feel like that should really be in Z though, so I kind of feel like these should probably be more like that, honestly. I feel like we kind of want to go through and clean that up into making everything actually specify things in 3D. So, you know, that's roughly what we're looking at here. When we go to actually render these things, we would also like to render them a little more sensibly there. I'm going to take a look in here. I think we've got entity rendering where we go through the pieces here, right here. So you can see here we kind of do our nonsense where we fuss with it a little bit. You can see where we do our dimensions, we actually kind of control that stuff by picking out the pieces that we wanted. And so what I'd point out here is, like, when we're doing a cube, now we could actually do this correctly. So X, Y, Z, like that. We could have this now be specified in its entirety. That lets us use full 3-dimensional specification for that, which I think we want. For lights, again, I think it should really just specify the dimension again, like so. Seems good to me. And so really, these folks just use the Y, which is fine, because that's, you know, if we want to just encode a single dimension for flat things, that's fine too. But it just seems like that's a good thing to just start with, getting ourselves properly set up for that. Now, since we're back in the game and we don't really care about the cutscenes much, I'm going to pop back over to handmade.cpp, and I'm just going to go ahead and turn back on the little... We've got this little thing that instead of actually playing the intro cutscene, what we do is we force the game immediately to pretend that the player one has started, so that we just boot directly in, which is a lot easier. So anyway, this is just exactly the same as it was before, or should have been. You can see that the lights are a little bit larger. I think because before, I guess where did we add pieces for lights? So I'm not... They shouldn't really have been larger. Let me look at where we were. I don't really care about these. So add lamp. When this calls add piece light, this stuff is kind of old and pretty worn out at this point, because it's gone through a lot of revisions. So when it calls add piece light, it just passes radius and an offset, and the radius gets spammed in here. So they really should always be the same size if we're doing it correctly. And so I want to see what's going on there. When we push a light in here, we're passing the piece dimensions. So are they always cubes? Yes, they are. All right. So I take it back. All right. So that's all well and good. Let's take a look now at how we're going to fix the part where this doesn't have any texturing on it. So if we go into the renderer, we've got the push cube call, and we're calling that directly. What you can see about the push cube call is it kind of specifies textures very explicitly here. And we don't really want it to do that because we would like to control where those textures are coming from. Now, we did do a little bit more of that. And I think, yeah, so this was our answer, right? Is if you want to change what the layout is, you can actually do that by using a set of tables that allows you to pick different cube layouts. Now, I think we probably don't want to have to specify that entire thing each time. So we probably just want to build a set of those. And the other thing about it is, like I said kind of later on, is this is just a big waste of time anyway. We could make it more efficient by having this be generated in like a mesh shader of some kind, right? Because we know that the assets for cubes are always laid out like this. So really we only need 3 pieces of information. Which tile to pick at the top, which tile to pick for the sides, and which tile to pick at the bottom. You could argue it's 6 pieces of information, like which tile for each side, and then the top and the bottom. But at a most, you're talking about 6 IDs, and each ID is just 2 bits, right? So 6 IDs of 2 bits is 12 bits. Even if you padded it out to 16 bits, you're talking about 1 16-bit value per cube is all we actually need to send down. But at the moment, we really don't have a way of sending down a 16-bit value for a primitive and having that get expanded out into different texture coordinates per vertex, right? That's the domain of something like a mesh shader or the earlier incarnations of that, geometry shaders. And again, I don't really want to go down that road. But what I might want to do is I might want to say, what if we do use a scheme like that for encoding it at the higher level, pass it down to the lower level, and then even though we're going to blow it out here, at least then we would be ready to do a better path by just directly encoding the 16 bits later on, right? So maybe we'll architect for the good thing now because it gives us an opportunity to do something nice there. And we'll kind of go from there. So I think what I'll do here is say, okay, let's encode in here a U16 that gives us that layout flexibility, and we'll make something that kind of works that way. So let's look at what that would be like. We would be passing a render or texture down that says kind of what the texture is in general, and then in addition to that one, we would be passing down a U16 that says like the UV layout, right? And I mean, maybe we can leave that in the same place, and we can say default cube UV as an actual thing here as well, because we can say that there is a default cube UV and maybe default cube UV layout, like so. And we could just say, in fact, we could just say that that's 0 is always the default, right? That gets us out of that business entirely, right? And so what that would be is that would be like an encoding of where we want which tile we want in each case. So, for example, we could say encode cube UV layout like so, and then in each case here, we would say, all right, there's going to be, you know, a top index, there's going to be a side index, and this is probably like, it's got to wind around. So we'll probably do something like this. Maybe I'll do top, bottom, and then side. I don't know. I feel like maybe that's better. So you say what's on top, you say what's on the side, so it's on the bottom. I suppose to be correct in order, it would have to be more like this. So it's bottom, side, 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 side. Sorry, east side. And I'm just going to go around counterclockwise, compass. So basically the same thing you get if you did sine, cosine. Right? So here we would just specify which sides we wanted, going all the way around. And then we have the bottom and the top. So to encode our cube UV layout, we would just pack these values into a U16. So the first thing I would do is I'd say I want each of these things to basically be packable into 2 bits, right? And assuming that they are, you know, we're okay. So, you know, let's make sure everything fits. Assuming everything fits, then let's go ahead and pack them together. So then we've got a result. And the result's just going to be all of these things ORed together. Right, we're just going to smush all the bits together. but we need to make sure that they don't overlap. So we want to slot each one in every 2 bits. So the bottom index will just naturally slot in there at the bottom. And I'll write it this way so it's clear what we're doing, but we're not actually going to modify it, right? The next one, well, we need to leave the 2 bits we had for the bottom index, so it's got to go up by 2, right? Then the next one's got to go up by that 2 plus another 2 to leave room for the side index, and so on, right? So we're just going to slide each value up 2 bits at a time. Excuse me. Look okay? So we basically put 2 bits, 2 bits, 2 bits, 2 bits, 2 bits, 2 bits, and that's all packed together. It gives us our result. And that, in this particular case, this U16, our inputs I allowed to be just regular integers. We want to cast down to make sure that it goes from a 32-bit to a 16-bit there, right? So that encodes a cube UV layout. So then what we need is a way to decode a cube UV layout. And I think really the only person who needs to do that is really the push cube call itself. So for the moment, I think we can weld that right in here, actually. And so we can go ahead and kind of work that into the specification. So here's the bottom piece, and I guess I should change this to do and say, if we eventually have mesh shaders in the renderer, we can actually save a ton of bandwidth by just encoding the 16-bit cube layout directly and expanding in the shader, because that's really all we need to do. So if we look at this bot stuff here, what we can see is, you know, we had a notion of this stuff before. The cube UV layouts, this stuff, right? So you can see exactly what it was previously. And what I'd like to do here is just start by assuming that it actually is the same, right? So we'll start by just initializing these guys like this. So this is what the bottom would have been before, I believe. Oops. So that's how the bottom gets picked. You know what I just realized too? So if we think about this, we actually have more bits available than we're using, right? If we were to think of this slightly differently. So we could also say, in addition to the encoding of which tile we're picking, we could encode the orientation of that tile. So for example, if we wanted to take the top and point it in a direction, you know what I mean? We could do that. Now, I don't know that we want to do that, but we could. So I don't think there's any point in encoding the bottom direction, because you can't really see the bottoms ever. They're really just there for lighting. In fact, we could probably just not even have them, as far as we know. So really, we would only care about the top. And the top could have another 2 bits that just said which of the directions it was facing. So I might do that. something like that. So basically we could just say, look, if the top is, or you know, I guess it's more like, more like that. So we're basically saying we'll spin that top one around because we might as well do it, so because we've got that that extra space. So that way we now are using 14 of the bits. And you know, I don't think there's really much else we could encode. You could flip, you could do a 180 rotation on the sides. I don't think the art would work that way, so I can't say that it makes sense to do that speculatively. The bottom I don't think matters, so I think that's pretty much what we're looking at. That's a pretty flexible set of information there. So let's just leave it at that. So we encode that cube layout. Now what we want to do is encode the rest of this stuff. The bottom really doesn't matter, but we're gonna, I guess we're aligning the pick. One thing that, you know, may be a mistake, is maybe what we really should do instead of packing them this way is move these up here and just have twice as many options for top tiles. You know what I mean? Because I just can't think of when we're ever going to use, like, you know, what's the circumstance where we can ever see the bottoms of tiles? I mean, we can see them when we do this, but our game, you know, is always going to look like that. And there's just no way to ever see the bottom face of a cube. I mean, I'm trying to think of the case where we would care what's on the bottom, but I can't do it. So I guess in some, here's going to be my fairly poor rationalization. So Handmade Hero is a learning project. And so as such, the decisions made in it are not exactly the same as they would be if it's a game that's just some game I made or whatever, right? We could, in theory, in the future, want to do ray tracing. Like, let's say NVIDIA RTX turns out to work 3 or 4 years down the line, and just turning on ray tracing makes a lot of sense. Well, maybe we want to have some mirror tiles that show the reflection of things that are on the ceiling, right? If we didn't specify anything on the ceiling, we couldn't do that. So adding reflections does seem like something that would be educational at some point, even if someone else did it, not me, meaning someone took the Handmade Hero code base and added that in there. So, okay, I'm going to leave them in. They're there. I don't know that I'm going to encode the rotation for them, though, because I don't know that we care about that. But, you know, we'll see. Maybe I'll do it just because it's symmetric and we have 2 extra bits, right? Like, you know, we could say that there's a bottom index and a bottom facing index, like so. And it would be free for the most part to do, right? If there's the encoding, then it just means we've got this instead. And hey, now we used all our bits, right? So that does feel kind of nice. It's nice to have used all the bits. You know what I'm saying? So that's good. So I think if we just said, well, let's go ahead and encode it, and we'll treat the top and the bottom the same, and we'll go from there. That seems okay. I don't have a problem with that, and off we go. All right. So let's take the bottom and the top and just weld those into place here temporarily, and then we'll do the sides. So, oops. So I'm going to grab this, put that there. Going to grab this, put there. Just grab these. So, and the first thing that I'm going to do is I'm going to do the sides, because the sides don't actually have rotation, right? So the bottom and the top, kind of reluctantly the bottom, but definitely the top, need to be oriented, and that's going to be a little bit different how we write the code. But as far as this one's concerned, all we really need to do is offset it by, like, offset it laterally, right? So this is the exact set of coordinates that we will use in all cases, right? Let me just go ahead and get this stuck in there. This is the exact set of coordinates that we'll use in all cases, except for the fact that we will slide them over. So the only change that's happening here is that it will slide relative, by 0.25 as we go. Right? Wait a minute. That can't be right. Oh, I see. We encoded them this way. I'm like, what? That doesn't make any sense. It makes slightly more sense now. And really, I probably shouldn't even do what I'm doing here. I only need one of them, so I'm not sure why I'm bothering with this. In fact, I'm not going to bother with this. Let's just grab them like this. All right. So that's what a mid panel looks like, and we just need to slide it back and forth, right? So what I'd like to do here is be able to set the mid results, and I'm just gonna try and look at where we've got these here. You can see how we're pushing the quads on like this, right? I feel like those kind of want to be arrayed so we can just kind of treat them as an array, I'm guessing. I don't really know how we want to do that exactly. I mean, one way we could do it is just like this. Right? And each of these is just a copy of that with a different offset. In fact, I could just do it like this. Oops. Because I don't know that I want to overcomplicate it. The ones for rotation will be a little more complicated, so we'll see. Maybe I want to overcomplicate those. But each one of these should be pretty straightforward. If we know what the cube layout is, from this parameter, we know that all we have to do to extract one of the facing sides is shift down by however much that side is, right? Then get rid of everything but the bottom 2 bits. So we're slide it over, get rid of it. We then have a number between 0 and 3 that says how far over we want it to be, right? So that's decrypted at that point into a number between 0 and 3. And since we know exactly how much we move over each time, we can just multiply that out. That gives us the offset that we need, and we can do it the exact same way for each of these. That is, if you actually manage to get the right number of parentheses. Right? So we can shift down mid x 0 by 4, then mid x 1 by 6, and other than that, the rest of it remains exactly the same, and these would follow suit in exactly the same way, right? So really trivial to decrypt those and then use them as offsets on the x parameters to basically initialize everything, right? Because the y parameter is always the same, so we don't really need to fuss with that at all. That's not necessarily true for the bottom ones, right? Those might, because we want to have the potential to code rotation, those are going to be a little bit more finicky. But for the moment, that's basically what we're talking about. Okay. So I think the only thing I don't know is whether these are encoded in the order that we want them to be, though. So let's make sure. We wanted this to be the eastward facing, right? So let me rephrase these. This is the one facing down the positive axis. This is the one facing down the positive y-axis. This is negative x, and this is negative y. So it's plus x plus y, negative x, and negative y is what we want to see, right? So here's the one facing down the positive x-axis. Assuming that I got this right, that should be 0, and it is. The one facing down the positive y should be 1. The negative should be 2, and then should be 3. So those are exactly what we wanted. We already did obey that convention. And again, that's just using cosine and sine as the rule so that everything always obeys that same rule. So we can loft this up a little bit and just say, well, we also know that our top x and our bot x are also computed the exact same way. So this computation here is also identical. And what we could do is get out the top and the bottom equivalently. I believe the bottom was encoded at 12 and the top at 0, right? There's the bottom and there's the top. And yeah. So I think that's all we need to do to make those slide over properly. Is use that as the offset. Now, again, we now have sort of this other issue, which is we need to figure out how to rotate the top and the bottom around. And if you think about what's going to happen there, really the only thing that's going to do is it's going to cycle these parameters. So all you would do if you're rotating one is you're basically shifting over which one is T0, which one is T1, and so on, so that T0 is now T1, T1 is now T2, T2 is now T3, right? So So I don't really know the best way to do that, but I assume it looks something like this. So assume that I capture one of these setups into an array, like so. Pretty straightforward, yeah? So I basically say, all right, I've got 4 coordinates that make up a tile, and off we go. Well, then hopefully we all agree that if I was to take one of these tiles and say, you know, that the bot tile is going to be, you know, a pointer to well, it's going to be hard to actually phrase that correctly. Let's just say this. So assume that I read these out like so, right? And maybe I do this. It's not the best way to write it, but, you know, what are you going to do? Right? So hopefully we can see that this would give me what I needed. And furthermore, I could do the top the same way. I would just have to offset the Y as well to get it there. Sorry, I gotta switch this to top as well, since I cut and pasted that, right? So if I take the version I used for the top and use it for the bottom, I'm sorry, the bottom and use it for the top, all I'm doing is looking for higher up in the bitmap, right? But that's all that happens here. These are the same as these, offset by 0.75. And the rest of it's the same, right? 2525, I think. So if we want to rotate these, what we could say is, well, if I want to never fetch outside of this array, no matter what I do, I can just AND this with 3, right? Hopefully we would agree. That makes it so that it can never get outside of the 4 elements that are there, because you could either be 0, 1, 2, or 3, and all the top bits are knocked out, so I know I'm always going to be those. So what that means is, if I then go and decode the facing direction, right, like so, I'm just going to take the UV layout and shift it down by 2 to get the, oops, sorry, this is the bottom face. This is the top face. If I extract those 2 values, I now know which of those facing directions I am, right? Now, I could AND it with 3 here, but I don't actually need to, because I'm going to AND it with 3 here, right? So I think we're pretty good to go there, because the only bits we care about are the bottom 2. We don't care about the rest, because they're all going to go away no matter what happened up there. So I think what I can do is just say, all right, bot face plus 0, bot face plus 1, bot place plus 2, bot face plus 3. And I think that just kind of gives me my answer, right? It allows me to rotate around what those UVs are, and I don't have to think about it much harder. Now, the thing I don't like about that is it does look like a lot of code. The indexing into an array part I don't love. So what I'm curious to know, is there some way to directly decrypt that value in some other way, right? Because we now have a value here that we could use. So, if we wanted to look at what this was, we've got 025250 and 002525, right? What we're basically saying is that 0 maps to 0, 1 maps to 0, 2 maps to 0.25. Let me just write this out for you here. And 3 maps to 0.25, right? I mean, that's what we actually said for the y coordinate. For the x coordinate, we said 0 maps to 0, 0, 1 maps to 0.25, 2 maps to 0.25, and 3 maps to 0. So what can we conclude from this? You know? Well, we'll start by expanding it a little bit. This is the bit pattern, right? So what you can see here is actually the y coordinate is trivial. All we needed to actually do is just look to see whether the second bit is 1. If the second bit is 1, it's 0.25. If the second bit is 0, it's 0. So we don't need an array for the y coordinate. We're done. The x coordinate, on the other hand, is a little bit trickier, right? Or is it? If we were to take these 2 bits together, what we could see here is, well, these 2 bits lead to 0 if they're the same, and they lead to 0.25 if they're different. XOR them together, right? So what we can do is we can eliminate this sort of semi-expensive stuff that I don't know. And again, I'm sort of thinking in my head here towards would I want this on a GPU? CPUs are fine with table lookups. Table lookups are oftentimes the best way to do things on CPUs. GPUs, I don't know. You're starting to get into finicky territory there. So I don't know that you would really want to be doing a lot of stuff like that. Although in this case, the table is so tiny that probably it's fine. Here the bit patterns are so easy. It seems like it might as well just be done with a direct bit encoding. It seems like reasonable to me. So if we look at this here, we can take what this bit pattern is going to actually end up being. And so if we know that the y is always whatever the second bit is, then it's really just, if we take this bot face here, what I can do is I can encode bot face in this case here, right? I can shift it down by 1 so that that bit is lined up, right? And then I can just AND it with 1. That gives me, for that particular face, a 1 or a 0 as to whether or not we want the, well, it gives us whichever one we want, right? It gives us a 0 or a 1, which we can then just multiply by the actual value we wanted, like so, right? And so each of those can be encoded in a pretty simple routine here, right? I can basically say, cube decode y, and we can say rotation like that. Or maybe I want to say, face and offset, something like that. So it's just face plus offset, and there's the value, right? I suppose we also might want to do this for like, what's the constant? Or, well, no, we wouldn't have to because we'd just put it in there. So I think that's all we really need. We'd just say cube decode y, and we'd say that it's the bot face and 0. like so. And then we don't need the tile lookup anymore at all, right? Oops. So now the only question is, what do we want to do here, right? And so now we need a cube decode x, which is basically the same exact function. It's going to take bot face in the exact same way. And so it's going to do the exact same thing. So we have effectively the same function. The only difference now is that it needs to be able to do an XOR. So instead of shifting it down being the only operation that we're doing, what we need to do is take that, right, which is this right here, this phrase right here, and it needs to XOR with itself. You know what I'm saying? So basically we need to take the face plus the offset, XOR it with the face plus the offset, shift it down by 1, and then that will tell us what we actually needed to know, right? All right. Leave that little comment in there. All right. Perfect. So let me see here. We got wall UV, wall start UV, wall end UV. So these are just ones we are going to want, like those were ones we defined up here, and we can now encode those into, in fact, that'll give us a good test. So now all we need to do is finish that off for the bottom cube as well. So inside Handmade renderer here, and we don't need this anymore, we can go ahead and encode this, the top ones, the exact same way. So if we grab this and say, here's our, you know, our top version, it just needs to use the top face and we're done. Now you'll note that the bottom face is probably not really correct. I guess I don't know how we decided to encode those UVs. So so we probably want to look at that at some point. I don't know when that point would be because I don't know who's ever going to use orientation on the bottom, like I said, but you know, it's there. The top, on the other hand, we're going to see right away, so that one will be an easy one to play with and get right. But there we go. So I think that's actually the encoding for everything, and now it's just correct, I believe. So let's take a look here. This is in the renderer test, so that's in the renderer testbed. So that's this. And what you can see here is we have wall runs going, right? And so in order to preserve those wall runs, we want to do here is we want to do wall start and end. We want to get those correct, right? So I believe a default wall UV is actually not 0. It's going to be the one that's in the middle. So I think it's actually, if we go into the renderer here and look at the encode, So encode cube UV layout, this one right here. So if we want to do encodings for these, right, what we want to do here is say, all right, here's our encodings. Here's our wall UV. We know the bottom we don't care about, the bottom facing we don't care about. The side indices, all the sides are going to be the same. They're going to be the one that's 2 over. And then the top, again, we don't really care. But it has to be 0 for now because I don't think there are any other tops in there at the moment. So that would be the wall UV. The wall start UV is going to be the first one in. So that's going to be this. And the wall end UV would be the final one over. So that would be 3. And now we can actually use the testbed to debug that code. So that's good. I need to delete these. And then I don't want to pass addresses. I just want to pass the actual value. All right, and so now this gives us a good way to debug that. So now we can step through and try to get those correct. It looks like we've got our bottom and top reversed, but otherwise it looks perfect actually. Oh, and you know why? Because we didn't add 7.5, so that's actually exactly what we would expect. On the top, you'll remember the y coordinate. So in cubic of y, it's just 2.5 there. So you need to offset it by the fixed offset to put it up to the top. So that may be it. Let's see. Yeah. So let's suppose we wanted those runners to go the other way on one of these. So let's suppose we wanted to encode a facing direction for the top, just to see if it's working, since we have a convenient way to test it here in the renderer test. So let's say that on the end UV and only the end UV, let's try rotating 90 degrees. Oops. Let's try rotating 90 degrees that wall end. The top piece of the wall end. So what we should see is it go like that. Yeah, and it is, right? So that's good. And similarly, you know, I could do a full rotation along on the wall one. So then we would see 2 counter-facing, but still 90-degree rotating versions of that same bitmap. Is what we should see going along the wall run now. So that one should be facing that way, and this is facing that way. Yeah. Let's make sure those facing directions are actually correct. I don't really know how to pause this in any particularly good way, but what we can do is take a look at the block orphanage here. So if it is just used with no modification, the bright side should point down. So what that means is a 90-degree rotation, the bright side points this way. So you know, if you just look at the bright side, right? I mean, you know what? Let's do the dark side instead. Dark side starts pointing up. Put it that way. So with no rotation, which I believe we did on the wall UV, I'm sorry, on the wall start UV, it should point up, which it does. So I think that's pretty much all we needed to really know, but I'm just going to double check again. So on the wall end UV, right, what we had was it should be rotated once, which in this case, actually that rotation looks backwards to me. That rotation looks backwards to me. So going around the incrementing by forward by 1 is not actually what we want. We want to subtract by 1 there. So there is one other thing I should probably do. Now that we're incrementing these probably do want to be anding so that they won't carry, right? Because we could get a situation, well, I mean, they can't really carry. Yeah, but if we want to do subtraction, we're going to have to, right? I think. All right, so yeah, I think that's all correct, but it looks like we kind of want to go the opposite direction, I guess. Let me see if that makes sense to me. I want to make sure I've got this right. Gonna load up Milton here. Oops. How much time we got left? Half an hour? Half an hour. So what we said is we said like, okay, here are our coordinates. It was like 0, 0, 0.25, 0, 0.25, 0.25, and 0, 0.25, right? So it's drawing that set of texture coordinates. Hopefully. For all I know, we did some weirdness in there when we actually had the cubes. But it's, in theory, doing that. In fact, let me just even check to make sure that that is what it's doing. It's, yeah, I mean, it's definitely going around in the counterclockwise fashion. Okay. So if this is the order in which we're doing it, and we have a particular orientation that we're saying, so we're saying this is the starting orientation when done in that form. If we wanted to rotate this so it was pointing that way, right? So if this is 0, this is 1, or let me do it with ABCs. If this is A, B, C, D, then rotating it 1 that way, right, if we want to rotate it, we would assign D to here, A to here, right, B to here, and C to here. So it is true that it is -1. The value you assign is whatever the value you were going to assign -1. So I didn't do that properly. Right. What I want to do in here is actually this. And I think that will still do the right thing because I believe that the binary wrapping that goes when you go from 0 to FFF will still produce the correct bit pattern because it'll still produce 2 1s in the bottom, which is what we wanted when you wrap. So I think that should still give us the correct result with only that change. Okay, so with the rotation, let's just make sure this is correct. So the wall start... Oh, sorry. It's actually not quite that simple. I negated the wrong parameter. It's face that actually wants to be negated. So it's really, the subtraction is this way, right? Offset is always correct. It's really just face that subtracts it away. So that was, sorry, my bad. I'm like, that's not going to be correct. That's going to be correct. Because face is the thing that's the rotation parameter, and the rotation parameter is the thing that subtracts. So let's try that one more time. So again, no change, and we should have the dark point facing upwards. It is a rotation of 1, and the dark point should be facing to the left, right? Which it is, and then a rotation of 3, and it should face it back the other way, and it is. So I think we're good. I think we're good. So I'm happy with that. Okay. So again, this is good because now we can encode that very, very easily, right? Now we can encode what we want to put on cubes in a very concise manner that's easy to pack into anywhere and doesn't cost us hardly anything. And if we find that our bandwidth usage is getting too high, it gives us a convenient way to eventually send that down. Imagine all of this and all of that going away, and it would just send down 16 bits to the GPU, which could then expand it out using the same logic, right? So that could save a ton of bandwidth there. Sorry, I'm a little sick, so I'm losing my voice slowly but surely. I could make it another 30 minutes, though. So yeah, that all seems good. I think that's just a straight up win. So let's get back then to what we want to be able to use that for, which is to say that we would like to be able to encode that. So now it would be pretty easy for us to encode that. So if we take a look at the visible piece structure, it would be pretty free now for us to encode that as a possible parameter here for anyone who puts a cube into the pipeline. They can now specify how they would want that to be textured. We know that only cubes would need it. Non-cubes wouldn't need it. So we may want to kind of introduce down here something that's just going to be extra parameters for visible pieces that really don't have to be stored separately. So only cubes would need a cube UV layout, right? And similarly, something like a trying to think, but like a light value, can store its emission there. So basically, any pieces can each of the types of pieces that might be involved, like cube or light, can store something extra in here if they need to, and they can be overlapping because we don't need to store it for everything. So if we look at that, that should pretty much do it, because that completely controls that part of the layout process. So if I was to go and say, now let's, when we add a cube piece, let's have them specify the cube UV layout in addition. So in entity.h, there isn't, I thought there wasn't there an add piece? Where did we put those? In RuneGen. Well, I guess that does make some sense. All right. So inside here where we do an add piece to an entity, and when we're going to put in one that's a cube, which I guess we don't really differentiate much. I do think we kind of want one of those, right? So we kind of want one where we say, here's a cube. So I don't know. I mean, we'll see how we want to do that, but when we do an add piece, we should get back the piece, right? Or do we not? We should, because you may want to make changes to that encoded version. So I feel like add piece should actually return to you the piece. You know what I'm saying? Like, you should be allowed to fuss with it, I would think. Oops. So I'm just going to go ahead and make these all return that information to you in case you want to specify something in there. Like so. And then the code for specifying the walls can easily just set those UVs as they wish. So let me think. So there's one other thing that we would possibly need. So I don't know. It's hard to say. But excuse me. We could also support mirroring. So like, instead of allowing the bottom to rotate, we could pack into those bits some mirroring. So a mirror bit for each of the sides, if you want it flipped that way. I don't know that we actually need that for any purpose. I can't think of a particular reason why we would, but it's worth noting. So I'll just throw that out there in case. We'll see if we hit it. I guess what I'd say is if we ever hit a case where we want to be able to flip things, then I would say what we do is we cannibalize those top two bits and they'll become the way that we do that. Because the bottom doesn't really need to be spun. Sorry, that's not the top two bits. That's the second two bits in. We'll switch those to be mirror bits. I think that's about it for that. So now we move on to the tagging part, which is kind of the more difficult part there, right? Because now the room layout code could just set whatever cube layouts it wants for everything in there. So now the problem becomes, well, what are the actual ways that this this visible piece is going to get picked, right? And the way we're doing it currently is we're basically saying, look, there's an asset type, and that asset type is going to tell you which texture type to look for, and then you're going to match tags the rest of the way down. So what I will say is I do think there's something to be said for retaining what amounts to a two-tier system. One where you select sort of the channel of asset you're looking for, and then the other where you set where you use information about the entity to pick an asset from the set. So I think what we would want to say, right, because just thinking it through, it does make sense to basically say this visible piece is an orphanage wall. So don't ever select anything other than an orphanage wall. And here's the part, here's the which part of the orphanage wall it is. But then you could dump like 10 different orphanage wall tile sets in there, and they could have stuff to do with like how wet it is, how damaged it is, how burnt it is, how whatever. All of those things could all just be fed into the system. And if there was artwork to reflect any of those things, then that is what you would get, right? So it does seem like that one is pretty straightforward, and we don't really need to go particularly far afield to figure out what the right situation would be there. And so adding something into a table that basically says this is an orphanage wall piece is probably what we want. And then anything that further specializes on orphanage wall piece, off you go. So I'm trying to think, in addition to that, I'm trying to think of ways in which this will be problematic. And really the only one that comes to mind at the immediate moment is that the act of searching through the information available to find the best match is itself fairly expensive. So if you take, the set of entity properties that are currently, on that entity, and you want to send them off to be matched against the asset system, you probably don't want to do that for every wall tile, every frame. Because as you get more wall bitmaps, let's say the artist just goes nuts at some point and decides to draw like 30 different bitmaps for this particular type of wall tile. That means you're going to search through a list matching a vector on 30 things for every wall, every frame. Right? I mean, every visible wall, but, still. That seems unwise. So I would suspect that at the very least, that information has to be cached and only updated when the entity properties change. I would assume. Now, maybe that's not true. It's hard to say. I mean, one thing that is true is it's completely parallelizable, all 8 cores of a modern CPU could all be sitting around doing nothing but matching stuff every frame. So if you really thought you were going to get some leverage out of it, in making it more dynamic and responsive in terms of as the environment changes, the graphics change along with it, then it's not entirely out of the question that you could do a bunch of stuff with that. However, it does seem to me that, you know, caching would possibly want to be on the table. And honestly, I don't think that's really a big deal because we need to cache the lighting information anyway. And we want to cache the lighting information only for things that are recently visible. And so I think it's been in the back of my head for a while that what I want to do is have it so that there's basically an entity cache that's used, that's like a least recently used sort of discard scheme that just stores transient entity info. So basically stuff like lighting and what the latest matches were for that entity for bitmaps could just be in there. And that's a scheme that's going to go in regardless. So it seems safe. You know, it seems safe to me. Now, if I go look at the file format stuff here, and I'm just going to look really quickly at sort of how this stuff was being done. So the way that it is encoded in the file is basic category is, you know, just encodes exactly the thing that I just said, which is stuff like, you know, what is this thing? Oh, it's like a basic wall piece or something like that. And so I think we can just say that's going to be that's going to be something that we just define to have meaning in our world, and we go from there. And so it really does seem like we could be fine with that. And off we would go. So let's take a quick look. Here was our original asset type ID for V0, right? This is what all this stuff looked like. And so if I just briefly move that forwards into file formats here, and really, I guess what we want to do is talk about the category now. There's just going to be some concept of an asset category, right? So there would be a thing that's like, you know, something like this. And these are like legacy things, right? So this is all legacy stuff here. That maybe if we do a full asset rebuild at some point, we would just get rid of. We could leave asset none in there for now, right? So here's all the legacy stuff. And so I think what I want to say here is, look, let's start with some basic stuff here. Let's call this like, you know, maybe this is like it's like wooden drywall is what it looks like basically, right? So I don't know how far we want to go down with this, but if we want to say that basically like there's a certain type of construction, it's wooden drywall, and we basically say like here's an interior wall, right? Or I guess this is really just a wall. If we just use basic categories like that and rely on parameters to get us the rest, such as damage, dustiness, mossiness, those sorts of things, I assume that's good enough. So basically what we would say on here is, the basic category is here. And we go from there, right? And these would remain in effect, but now we can like import these three things in there, right? And then for forest, we would have something like this. I mean, possibly. It could also be that we really want the grassiness of something to sort of be a parameter. So we may want to do something a little bit differently, where we would say something like, that's sort of like a field, and we would have a grassiness parameter, right? But in terms of the blocks we have, like that would kind of say which one we wanted. And if we imported those assets in and assigned them that way, and had some tags to describe those, then I think we're basically where we want to be. And so I think that's roughly what we want. Let's see here. I think we're just going to basically update this enum, and there's probably not a lot more to it than that. Oops. And now I like that naming better because asset type was not a particularly good way of talking about assets, because the type of an asset makes it sound like we're saying bitmap or sound, whereas category lets us know that we're talking about sort of like, a genus, like, is it an animal? Is it a wall? Is it a, treasure chest type of thing? Like what's the actual category of it? So distinguishing between a type of asset, which may be a physical thing in a file, which maybe the asset system always needs to know about. A basic category is more of a matching information, like, oh, you can restrict the matching to this thing, a priori kind of a thing, right? Seems a little bit better. Let me just... asset basic category. So yeah, I think this is reasonable. So we're really not, it looks like, honestly, we're not going to really have to change things much. It looks like we more or less had the right idea, at least for this particular version. So really, I'm just going to rename that old version to a more sensible name, then type. And I think that may be all we really need. At least for walls and floors. Seems like that should be fine. And then we'll try it with something harder, like a monster or the hero, and we'll kind of go from there. Again, really, this is just boring busy work. There's nothing to say. Pretty much just exactly what it looks like. Just kind of changing the nomenclature a little bit. All right, so now that that's done, what we should be able to do is tomorrow, and I'll stop it there. Tomorrow we should be able to go build import tables for importing things like those block files. So tomorrow we should be able to basically change this room into something that has proper walls and a proper floor. And unless we hit a snafu there, that should be what we do tomorrow, and it should be fine. We should also be able to make it so that if you walk out here into what should nominally be like the other part of the world, we gotta eventually do our final camera code too. Once you get out here, it should be a forest, right? And then there's, oh right, we need downward as well so we can get dungeons, right? We've got dungeons in there, right? You can go underground and stuff. You can see them. So we want to make all that happen too. So tomorrow we should be able to do all that, and that'll get our art importing, seeing if that works roughly the way we think it should. So, and we can again just keep iterating on it till it's good. I'm going to go ahead and go to the Q&A now. In the renderer test, the corner blocks that are on the side of the building have their diagonal beams reversed due to sharing their texture with the front blocks. Do you have a plan for handling that? Yeah, that's actually... So that's just because the renderer test isn't encoding that information into its database, right? So if you look in here, we just have all of them use the same UV, right? So all the sides use the same UV. If we instead in here actually encoded different kinds of wall starting, right? Then, you know, we wouldn't have that happen. So, you know, we could, if you wanted to make the renderer test app a little bit more fancy in that sense, then if you looked here, you could go, okay, in the test scene, we've got the test scene element, and it's got these sort of parameters. Is it grass? Is it tree? Is it, it's a wall, whatever, right? You could decide to make it more explicit here and record what encoding you wanted as well. So for example, suppose you did that, and then you did this. And now we said, hey, right? That would give you the ability to encode that information and then use it later. Now, as I'm typing that, I'm kind of glad you asked that question because again, we wanted our renderer to kind of be something used outside. And so what that suggests is really this, should be a thing where we, do something a little bit more like that. Because we'd rather have people use an explicit encoding where it's not just a U16, because what if later we decide we really need 32 bits to encode our UV layouts for cubes? Well, now everyone has to change their code rather than it just working. So wrapping it in a struct, again, because we did decide we wanted the renderer to be a little bit more of a first-class citizen, something that is possibly useful outside or being used by multiple people eventually and so on. I think we want to continue that idea and not sort of cheese out when it comes to making additions to it. So, it would look something more like this. Something like that, right? So then when you say encode a UV element, you're actually doing this. And when you pass a UV layout here, what you're actually passing is something like this. So you can sort of pass something if you want to. You can ignore it and it'll just automatically construct the one that's nothing. But otherwise you can create one here. But it's always make sure you're actually talking about a layout and not accidentally passing some other thing, right? And so that seems pretty good. And let me just go ahead and quickly update the code for that because I think that's a worthwhile change, right? Oops. And so here where we talk about UV layout, all of these are actually just the encoding on the UV layout, right? So that's easy enough. And then everyone else who passes something in just kind of has to deal with that. Now, I don't really want to do the render test just yet. I'd rather work on Handmade Heroes one first to make it, well, all right, I'll do the render test first. Whatevs. So here we just need to know that we're checking the type field instead of well, you get the idea. We just need to use the type field instead because we've now said that there's an actual struct here, right? So now what we're saying is, well, the scene elements in this case, right, equals a particular element type. You can see here we're doing like the wall here, and here we're doing some other part of it, blah, 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 right? So in this case, we can just do this, although we're going to want to do something fancier in a second here, right? And then actually, so I guess we can even do it. Well, I might as well just encode it here. So to retain the exact same behavior, we're not going to fix anything, but just encode the exact same behavior. If we were to put the UV stuff here, then when you place a rectangular wall, here's the encodings for the basic wall stuff. What we would say is that as we come through here, we're going to want to set these elements to something in particular. So we need to do this. So we're setting both of these to whichever one of the element types that would appear. It's just going to be wall in this case. because now we don't have to set that anymore. And then we need to set the UV layouts, right? For each of these. Right? So it's actually this statement here, and we don't need this anymore because it's not changing. So really, this statement here is the thing that's going to control how these cube UV layouts actually work, right? Right? But it's even a little bit more complicated than that, because we're going to have to switch the Y's as well. But for right now, we won't do that, right? For right now, we're just going to do the same one as we did before, right? And we're not going to do anything else fancy. So we're just doing the basics here. And so for these are just element wall. So they would be, well, I guess I can actually do it exactly the same way since they're both the same. Right, so that will set UVs as well now. And these, of course, are now a real type. Right, so again, not doing anything different here. I'm just taking something that was done at runtime and actually just recording it now into the database of the test renderer, if you will. And place random in unoccupied scene test element type. And so here I'm just going to go ahead and set just the type there. And in here, we're just going to do that. Although actually, so in this case, we don't need to check for all of these anymore, right? We can just check for if it's a wall, because that's the only one we actually needed. And then what we can do is anytime that we're pushing one of these, when we look at like the type and look at what we're pushing, we don't need to change anything here, right? Because now this is encoded in the database itself. So what we can actually do is say the element cube UV layout just gets passed directly there. And now we don't have that sort of switch determination. Okay, so here we would just say default cube UV layout, because we don't care what it is for light. And there's probably one other place where that needs to happen as well. Yeah. So here we wanted that, although we actually now know what that is. So when it's cube, we want the cube UV layout. So we can actually just fix that piece of code to actually do that now, because we know we're going to want that eventually. And our entity piece can have that too. So basically that just cleans up that so that now everyone is always correctly talking about cube UV layouts, right? And so now if we look at the renderer test, right? Now what we want to do is actually, so that's kind of interesting. I wonder why that, did I set that wrong or something? I probably did. So anyway, so now that we have each one of these able to be encoded directly, when we actually go to lay out the world, what we can do is, encode the layouts correctly for every piece now, right? Oh, right, because there must be, well, oh, right, so this is why. Right? We want to be able to set that wall UV to the wall to not the default in the case where we're in the middle of a wall run, because that one doesn't get any of those pieces, right? All right. So now we're back to the original behavior, but it's all going through the data set rather than anything else. So let's go ahead and fix the problem you were talking about. I believe the problem you're talking about is that one right there, for example, right? And so what we want to do is set the correct things on each type of the various cubes. So for Y's, you'll notice these don't ever get that. We do need them to set. I'll show you why in a second. But let's just focus on these for now. So what we want to do here is maybe change a little bit the way that we're doing this. So what I want to do here is say, look, here's the wall UV, and instead of considering there to be a wall start and a wall end UV, instead what I'd like to do is actually just talk about the encoding here directly, right? So what I'd like to do is say, we're going to encode into like the wall start or something, right? We're going to encode the entire thing here, and the same thing is going to happen here, right? And the reason I'm doing that is because they're going to now be different, right? Let me lay it out this way. Okay, we're instead of always setting it to the same thing, no matter who you were, they're actually going to be different now. And so I want to encode for every piece an actual unique set of values so that I can do that more explicitly. Now, I don't know that we actually want different rotations here. I'm going to leave them as 1 for now because it was kind of a little bit fun. So maybe we're going to do that, but we'll talk about that a little bit later. All right, so let's take the min-x case. So the min-x case has 2 cases. There's the one at the top and the one at the bottom. On the far side, this is the left side of a wall, the topmost or the bottommost one. So y goes that direction generally in our system. So that means the min y is the one that's closest to us. So if we think about what sides need to be on there, well, the side facing that way, it doesn't matter. And the side facing that way, it actually doesn't matter. So it's only these 2 right here that we care about. The one that's that way, if we think about what it needs to be on there, that needs to be the 3. That needs to be the one that's gonna like start a run going this way. And the one that's facing us needs to be a 1 because it's gonna be the one that's facing that way. And so that's how we would encode that one, right? And so let's look at if that did the right thing in the renderer test now. So let me run the renderer test. And you can see us kind of coming up on this wall here. Again, we didn't change the encoding of that, but here we did change. So that's still pointing the right way, so we didn't screw it up. We want to see this side right here, and you can see now that that's facing the right way. But that one still isn't, right? Because we haven't touched that one. So we now, our lower left corner wall is now correct, if you will. But our lower right corner wall isn't, and that's really the one we want to work on. What the heck happened there? I didn't even know you could do that. Okay, well, yeah, that seems wrong. Are we missing our top? Oh, looks like we are. How did we? That's how. Sorry, I accidentally deleted that. These both need to be set to wall. Okay, so anyway, let's go back to our lower right. So this is our lower right case. And so again, if you think about it, 2 of these don't matter. So the one facing that way is like interior. We can't see it, so it doesn't matter what it is. And the one facing up, we can't see either. So those 2 are just irrelevant. And so that's this one here, right? And this one here, we don't care about. So it's this one and this one are the actual ones we care about. So this one here is the one facing out that way. That's going to need to start the run, so that's a 1. The other one is a 3 because it's starting a run going back the other direction, right? Now, in neither case have we looked at the max Y run, so we only did those first ones there. Excuse me. But this side should now be correct. And it is, so you can see it there, right? All right, so we've done those two corners. Now let's talk about the far corners, perhaps, which are the ones that are on max y. So the maximum y, maximum x, right? If we, again, go around the horn, so the one facing this way is an end tile. That's actually correct. The one facing up should be a start tile, I believe. So I think this one should actually be a 1. These two are interior, right? Yeah. So the min x is the one on this side. Again, the one facing up. So if we were looking at it this way, it's actually an end. So that's this. I'm sorry, that's not facing up. That's facing up. So the one facing this way we don't care about. We can't see it. The one facing up is the end. The one facing to the outside is a start. And so it should look like this. So I believe that's everything that we needed to get there, right? And so now I think if we just were to look, all of our exterior walls would be correct. I don't think we would have any more that are wrong. And that's why I did that cube UV encoding the way I did it, right? Is I knew that we had to do this at some point. And so I made it so that you could explicitly encode which panel you were picking for every single side, right? And so now, like, we just really shouldn't see any where it's bogus. Hopefully. That all looks right. And so now the only question would be, like, you know, what do we want to do with interior walls, right? Like, what do we want to do? Because you'll notice we haven't set any of the interior wall pieces to anything at all, right? Like, the interior wall pieces are basically just always blank. And so if we wanted to have those interior wall pieces also have the correct beaming structure to them, we could do it, right? Let's check when this piece rotates into view, by the way, to make sure we've got all of our beams correct. Yeah, looking good. So those interiors, you can see those are all white with no beams. And maybe, you know, you want beams in there. And so let's suppose we wanted to have the beams in there. What we need to do to check for that is we need to look at min x like -1 and max x like -1 kind of situations, right? We need to look at like one inset. So here what we would need to do is repeat this case again, right? There's just a lot of special cases, but that's just the way it is. So if we were one out or one in, then what we know is that certain ones now are going to be visible. So let's say we're one in from the end. Then we now know that while most of the time everything is just a blank wall, right? So most of the time we're just going to set to, oops, that's not a blank wall. That's a blank wall. So on this, each one of these will only have one visible strut, and it's only and only one. So the rest of them should be blank. So if we look at one in from the left, so min x plus 1 is one in from the left, then we know that the only thing we want is the southward face, right, should start a run. So it should be one of those. Similarly, if we're on the, sorry, no, that's backwards. That's on the max y. That's the furthest one. On the closest one, the one in, it's only going to be the northward face, and that northward face, if we switch it around, is going to end the run, right? So it's going to look like that. Now, if we're on the max shrunk in, so we're on this end, if we're on the earliest, then it's the northward face, and if you think about it, that's going to start the run. And so parallel-wise, if we look at the furthest one out, we're going to want the south face, and that should end the run, right? So that will make it so that now we have proper interior beaming on the left and right sides, not the tops and bottoms, because that's the other path. So if you look through here, what you can see is now if we get the top, well, we're not going to be able to see the top, are we? We need a free look mode here. We got to get to a place where we can actually see the tops of one of these. Hopefully we'll pan to one in a second here. But now we should have it so that that there's a strut there. Okay, and the fact that there isn't a strut there would suggest that I'm totally wrong about that. Not great. I'm going to need, if we keep down this path, I'm going to need a way to do that a little bit better. So on the max Y, that's rightward facing, northward facing, leftward facing, downward facing. That should have done it. Aha. Sorry about that. Missing an else clause there. Although I don't think that would have done it. It would cause this to clear in some cases, but not the one that I cared about, I don't think. Oh God. All right, so maybe that was the problem. We didn't even get a clean compile, did we? All right, there we go. Let's take a look one more time. That missing else should have created more bugs, and I was wondering why it didn't. And the fact, I guess we just didn't compile would have been why I wasn't paying very close attention there. Yeah, okay, so now there are the beams. I can actually see them in the off in the right there. So I think both beams are correct on that part of the interior now. And so now we just need one more, which is the vertical beams, right? So that looks right. So now we just need one more, which is the vertical beams. Also, I really don't know what we want to do about the roof thatching, like the tops. I'll leave those as zeros for now because I don't know what else we would do there necessarily. But yeah, they is what they is. So all I'm going to do here is just special case this one part here. And so all we need to do is the same thing I don't know why Farcoder did that. So all we need to do is I special case the Y's. And do them in the exact same way as I did the X's. So assume that they're just a normal wall like they were before. And then all I'm going to do is say, well, okay, so for the case where the Y is one in from the min, right, which would be the first one there, or one back from the max, I'm doing a run of X's here, right, from min to max. So if the X wait a second. So the min what did I do here? I'm a little bit confused. So I do a loop on the x's, and I place the x's Oh, okay, sorry. I guess I've been programming a little too long today. I forgot I cut and pasted this code from the thing above. I'm like, what am I doing? That shouldn't work. Of course it shouldn't. I just cut and pasted it and I have to update it. This is the code I should have been looking at, and it works just fine. It uses min and max. I'm like, it should be y with min and max x. Well, parentheses, it was if you actually looked at the actual code. Never mind that. All right. So what we actually want to do here is this. We want to make sure that this stuff is presented correctly. So in here we've got the min x and the max x, the min x and the max x. And so we just want to do the exact same thing here that we were doing before, where we just say, look, let's make sure that we put the right beam on the right side. So in this case, we've got the minimum y, which is the closest to us, 1 up. So we're talking about the two like bottom left, bottom right interior pieces, right? The min x is the one on the left. So that one is going to have its first one right here be a start beam, right? And then we've got also on the other side, so the bottom right on the interior, right? Don't care about anything up till the one that's inside facing, so the one that's facing into the interior of the building. That's going to be the end of a run, right? And so then here we also have the exact same thing happening where maximum y is the top, right? 1 in, so the interior is there. So the minimum x is this one. That's that first one that's facing in. That's going to be the end of a run there. And then similarly, we're going to have the exact same thing happen here. The other one is going to be an end of a run on the other side. I'm sorry, the beginning of a run on the other side. So I think that should be the complete set, I believe. You also have to make sure you close your brackets, or braces, I should say, if you actually want your code to compile. And I think that should be it. And by the way, that's code. We needed to do that because we actually need to do that exact same code in the actual game as well. So it's not wasted work. We'll just duplicate that logic when it comes time to do that inside Handmade Hero, because we want to be able to do those interior runs properly as well. If that makes sense. Looks like that one on the interior was wrong. Looks like I had those backwards on the Y. Oh, you know why? Because you can't have something that's only one long, because you can't put both struts in. So it's not wrong, it's right. It's just that one was too close together. But you can see it now, right? It's all kind of built together. When will we use the new for-coder update? As soon as the picker thing is working. It's too slow right now, but it's when it is fast, I will be updating. All right. I think that's it for today. We've done quite a bit. But that all looks right. You know, like the beams look good there, right? All right. I'm gonna close it down. All right. Thank you, everyone, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along the series, you can always pre-order the game on handmadehero.org, and it comes with a source code, so you can follow along at home. We'll be back tomorrow when I'm going to start putting that same stuff that we were doing in the renderer test. We'll just put that into the game proper, which I think will be really nice because then we can start to define areas of the game better. And start to kind of bring them more into like to give a little more of a feeling of exploration and sort of feeling of the actual gamey environment, which is always kind of nice. So that'll be fun. I'll see you back here, same time, same place. Until then, have fun programming, and I'll see everyone on the internet. Take it easy, everybody.